Welcome to the Testing Habits podcast. This is Eduard Enoiu. Today I'll be speaking with Serge Demeyer, professor at the University of Antwerp, the Department of Mathematics and Computer Science. He's the spokesperson of the ANSYMO Antwerp System Modelling Research Group. He directs a research lab investigating the theme of software reengineering, lower lab on reengineering. We'll talk a little bit about software evolution, software testing, test automation, education, and many other topics. Serge knows a lot about many things, as you'll hear in this conversation. I love talking to Serge, and I hope you enjoy the ground we cover. So, Serge, welcome. Thanks for being here. How did you start your career in research? I'm really interested in to know more about what made you, go on this path.
Now, I graduated in Brussels, in the Brussels Vrije Universiteit. And in the beginning, for me, it wasn't about research. It was about teaching. I wanted to be involved in talking to young students. Back then, we were starting with the whole scheme as a new programming language. And that what threw me into academia. And then I did my military service, and then the professor asked me to come back. And then that was the time when I actually said, okay, perhaps I should do a PhD. And we were participating in this project with some bunch of sociologists on how to use hypermedia to do collaborative work. And so, that was really what made me trigger for research, this whole computer-supported collaborative work. And that's since then ever, for me, it's not software, it's to serve mankind. And that's still what I want to do.
Yeah, so you graduated from Brussels University?
Yeah.
How is that? How is Brussels University? Why?
Brussels is a bilingual city, and so there's a French-speaking part and a Dutch-speaking part. And so I was part of the Dutch-speaking part, and that was on a nice little campus close to the police offices. So I remember when, as a student, you sometimes walk in a little bit toxic circumstances across the campus, and then you come across police officers, but they usually keep very quiet against the students. But that was a nice period of my life.
Yeah, and what did you like the most about that period where you, I guess, started to learn about computer science and maybe engineering? Was that something that attracted you?
Yes, I was already in middle school working with the first Apple IIs, and so computers was something like, wow, this opens up a new horizon. And my parents were very skeptic about that, because they said these weird machines who can calculate. And then I came to the university, and it really opened my eyes to all the possibilities that could be. Back then, we still had to program on these typewriter things with black screens with green letters, only 40, 80 characters, that type of stuff. There were even some Ponsing machines then. But we quickly adopted graphical interfaces, Macintoshes in the beginning. That's what really opened my eyes.
Yeah, and it's interesting to hear that. And but I guess it's a long way from there to going into research. And I guess that came sometime when you were, I guess, after you graduated, or was it before?
No, it was after I graduated.
It was after.
I first did a year of teaching, then a military service, and it was only after that research and PhD research in particular was kind of my thing.
Yeah, I'm just curious about this aspect, because I'm talking with people with different backgrounds, and I always try to ask them also about what they did research in the beginning. What was the subject they actually started with?
Yeah, so it was, we had a project together with sociologists, and it was really about making decisions in group. And so there was this kind of special voting mechanism to avoid that people with authority would kind of hijack the group. And so we actually had yeah, that was in the early days when graphical user interfaces and so on were not that thing. So HyperCord was still there. So we used HyperCord as a way to stimulate and allow people to discuss online. Yeah, that was before Zoom and Teams and so on existed. So that was the early days. And yeah, that was what drew me into it.
Yeah, and it's interesting to say that, and I guess not too many people were doing research about these aspects, or have you found many many colleagues there?
That's not true, huh? In Brussels, it was a programming languages lab, so we were investigating novel ways of programming, the early days of objects and things like that. But back then, I went to the hypertext conferences and the computer-supported cooperative work conferences, and so there are already late 80s conferences regarding that.
So you started early, and I guess, nowadays when you see more and more researchers doing, I guess, research in social aspects of computer science, software engineering, I guess that brings you joy.
Yeah, sure. It was also an interesting time, because back then the internet did not yet exist, and so we actually had to go to the library to borrow proceedings. So yeah, if you wanted to know about the related work, you actually had to wait 6 weeks before a paper arrived on your desk, and that's amazing.
Yeah, it is amazing.
So back then, when you wrote "to the best of our knowledge, we are the first doing that," that was really true, because you didn't have Google to help you in doing that.
Oh, you had to go to the library to actually
to the library, and then microfilm still,
Yeah. And I want to say here that I read some of your papers before I met you, and I know that I got inspired by some of your work, and I'm sure others have done also. And after I met you, and I think I met you also in a research project meeting, and I remember seeing a book called Object-Oriented Reengineering Patterns book, and then it clicked. Oh, that you're the one of the authors of that book, and I it's amazing how small the world is, especially in research. So I was just curious, how did this book come about? It is such a popular book, I guess.
Still. That's you really go back in time. So after I finished my PhD in Brussels, I had an opportunity to go to a European project in Switzerland, and that was with Nokia and Daimler-Benz, and they had this huge piles of legacy code in C++ and Ada, and they wanted to refactor it. And I was there as a postdoc. That was my first experience with a European project. So we had to fly to Helsinki in cold winter times, and there was also a Spanish partner involved. So also in summer going to Spain. So that also was an interesting aspect. But we were working on this legacy systems, and back then that didn't go well into research papers. So we actually submitted papers, and reviewers told us there is no such thing as an object-oriented legacy systems. No, we knew that was not true, because we had actually industrial people suffering from legacy systems. But we were there to help them. And so one of these deliverables of that project was a handbook, which we wrote together with a team in Karlsruhe. And Martin Fowler then had his refactoring book out. And so we said, this looks interesting, but we wanted to go a little bit higher level, so next level. And then that was also the time when the design patterns book was there. And so we said, let's do something re-engineering patterns. And we started to scribble a few things, and there existed the Europlop series of pattern language conferences. So that was, compared to other conferences, something weird. You had to go someplace in Germany, in some castle, something like that. And then you sit together, you play games to exercise the left part of your brain, and then you actually have the pattern writing workshops with to do the right part of your brain. But yeah, it helped us in writing these patterns to something which was helpful for practitioners. And so that's how this book came out. So we had the handbook from the European project. We completely rewrote it, and then we actually submitted it to a publisher, and then it was reviewed in several times, and then it was already back in Antwerp then before it finally got published. But so that was interesting, and then we got several good reviews and remarks from that, from people actually using it, but it didn't sell so well.
Okay.
So after a while, Morgan Kaufmann, the publisher, told us they will not sell it anymore. And then we asked if it would okay to get the copyright back. And then we did, and now we have a free version available on the web for everybody who wants it. And I still get occasional emails from people saying that it helps even now.
Yeah, I'm sure. I will actually put also the link in the notes so people can check it. Yeah, it's. I was just wondering how is it to write a book? I guess you wrote this book, and I've seen also a book on software evolution.
Evolution, yeah.
Yeah. So, is it fun to write a book on engineering or software engineering?
Now
re-engineering.
I'm writing a book on software testing. So is it fun? Once it's done, it's fun. But the moment you're writing it, it's hard work. And back then there was no such thing as Git or something or Overleaf. So we actually had to email back and forth files with the content. But once you have the first draft available and reviewers are reviewing it, and then for especially with Morgan Kaufmann, there was copy editors going over our language and helping us doing that. Also the layouting of the book, that was fun. And then I also saw the other side of producing a book and how engineering wise that goes into all kind of stuff. So they actually copy edit with manual annotations on the paper on things that should be changed. This goes to the font level. So.
Very interesting.
One interesting part was also that we wanted to have a CD with our book.
Okay.
Yeah, and then we contacted the publisher and why do you want to have a CD? Yeah, because there are lots of tools available on the web and we would like to put them on the CD. And then they told us, a CD, if we need to burn a CD, we need to immediately burn 1,000 copies of it because we do that in one batch. But for a book, that doesn't happen. So for a book, they publish in small batches. And they actually change little things between the batches. So there's typos and things like that they do. So the whole production of a book, if you see it from the other side, is really quite different than what you would expect. So I learned a lot from that.
You learn a lot. Yeah, that's useful. And I guess it's still important, this topic. I mean, the reverse engineering of legacy systems. This is something that has been it's very important.
Oh yes. And I now do lots of work with cyber physical systems and companies thereon, and they still struggle with that.
Yeah, I was wondering, how did you switch from software re-engineering to software testing? I know you from at least I know you from that side of software engineering and research.
Well, that's quite a natural step. So we were doing all this work with Nokia and Daimler-Benz and about refactoring and things like that. And the point was that they do know how to refactor, but what's mainly was preventing them is that they didn't have these automatic regression tests that you need to refactor. And so for us, that was also in the book very prominent. You need automated tests. And that was the beginning when there was the open source testing framework, Smalltalk unit testing. That was the first, and then Java, JUnit, and then a few others. And we quickly jumped on that wagon. And so for me, it was clear, test and tests, automated tests also need to be refactored, because before you know, you have thousands of them with clones in between them. We do lots of work on clones in normal code, but we also then did work on clones in test code and things like that. And then how can you refactor and maintain your test code? So that's how it came. And so I'm done to research in software testing. I'm to research in automated tests and the code that goes along with it, and how to make that code clean and healthy. And that's
it's interesting that you're mentioning this, the difference between testing and test automation. Do you see as are there any aspects of testing do you see that is, I guess test automation comes with something very important, and you're trying to automate some parts of the testing process that make that bring maybe more efficiency, I guess effectiveness in the process. But is this why do you make this differentiation between, I do research in test automation, and not, because I guess test automation can influence other parts. I guess a tester will do also manual testing and implement automated tests. I guess it's what I want to get into is that is there a significant difference between these areas?
I think so, yes. If you do research on testing, it's really about the last 5% of the bugs that you know about. But if you do on test automation, especially from my evolution perspective, it's about regression testing and making sure that nothing breaks. And so your tests don't need to cover 100%. If they cover well enough that you notice where it starts breaking, that's good enough.
Interesting.
And that's why the automation is so important, because it's you need to run this several times. And back then we had things like every quarter a new release, but now people on Git commit every 5 minutes or so. And so then you need to make sure that if you commit, that you don't break anything.
Yeah, and are there any, specific research that you would like, you think are the most interesting, in test automation? You mentioned the maintaining large test suites, but I was wondering if there are other things that you think are, important.
Well, yeah, recently I'm on a mission, and you know that, with mutation testing. So this is now my new pet topic, where I actually, want to explain to people how important it is. And so I started this with a research paper where we actually were changing things, and we wanted to see whether the tests were good enough. And then we measured line coverage and things like that. And then a PhD student of mine came along like, but there exists mutation testing, and that's even better. And so an academic started to read upon that, and in academic circles, mutation testing is the best thing since sliced bread. Especially I have lots of industrial contacts, and it was clear like, but that's very expensive and it takes too much time and things like that. And then we got in contact in Sweden with Saab, where they had this tool on C++ mutation testing with Clang. And he also had some contacts with people in the C++ community. So I said, it would be really good if you would have a C++ mutation testing tool. So we helped a bit there. We also deployed it in actual industrial circumstances and on components where the team was thinking this is really well tested. We have over 90% line and statement coverage. And then we did the mutation testing, and we still could find weaknesses. And that was interesting because, that's kind of expected. But then if you then actually start to talk to the testers, they go next level again, because for them it's not about having 100% coverage, but it's also about how can I design my test architecture so that it's easier to test. And this mutation testing also gives hints there. And that's what now for me the mission again is how you can use mutation testing to actually improve the maintainability of the tests. It's a way to, it's more than just finding weaknesses in the test. It's also about the design principles that go along with it.
Yeah, and maybe for our listeners that don't know mutation testing, maybe we can just tell them that mutation testing, I guess it's used to create new test cases, but also to evaluate how good your test cases are, the quality of existing tests. But maybe you can tell it in a better way.
The way I try to explain it is when you go to the airport, you need to go to the security gate. Yeah, and they put your bag under this camera and they have X-rays to see whether there's any revolvers or something like that in it. And what happens is, if you want to test the security people, what they do is they artificially inject revolvers and other bad items into the image of the suitcase to see whether the security people actually catch it. And that's what mutation testing is about. So you have your system under test and you have your tests. You inject artificially faults in your system under tests, and then you see whether the tests actually catch it or not. And if they don't, you know that's a bad sign. That's something where you should improve.
Yeah, I mean, this is a very, very interesting, a very good way to put it. I really like it. I might use it, but I will for sure mention your name.
I have a slide somewhere where that I can share with you too.
Oh, that will be great. I'm wondering maybe if we go into the nitty-gritty part of of mutation testing. Do you have any opinions about the experimental, but also the theoretical aspects that underpin mutation analysis and mutation testing? For example, the coupling effect. And is that something you think about? And I don't know if you have any opinions.
I do have opinions. So the coupling effect is if you have if you have a small error, that it should be found out by the tester. And so, that's again what I said. For me, it's not about being 100%. It's about, are your tests good enough to catch the things that matter? And so in that sense, mutation testing helps. We are currently doing mutation testing on MATLAB Simulink models with people in the modeling community. And that is not anymore about all possible faults you can inject, but you really want to inject the faults that matter. And so we have one little Lego robot where we have the wheels, and then we start reducing the wheel and reducing the wheel a little bit more and reducing a little bit even more to see when it's not possible anymore for the robot to follow a line. That's the kind of mutants we want to inject also in the real systems. And that's the kind of thing we're currently working on.
And more realistic and more, more realistic mutants you use, the better results you have, I guess.
That's the hope. But then, for the moment, we don't know that yet.
No, I really like this discussion. I think we can go on and on about mutation testing. I'm pretty sure. But since we discussed about industry and how your current mission is to promote to some extent mutation testing, and you'd like the industry to know more about it and use it, and I know that in industry you always find people that have, what we call preconceptions, biases. They have some preconceived views about some aspects of software engineering. What is, in your opinion, one common myth that you would like to debunk about software engineering?
I'm not really that happy with the whole negative aspect of the metaphor of software engineering, in the sense that it looks like, we're not proud of ourselves because all other engineering disciplines deliver on time within budgets without faults. That's not true. Huh? I had people here doing work in my kitchen. They also screw up. They also go over time, over budgets, and they also make mistakes. So it's not true that other engineering disciplines do better. And on top of that, I think we can actually teach them to become better. Because if you see this whole agile way of working, this whole Scrum, this whole Agile Manifesto, the way we do engineer projects now is some place where we can educate other engineering disciplines on how to do really exploratory design and deal with novel things. And then, especially if you now look the way we develop code on the internet, on SourceForge, on Git, where we share code, where we share all the changes in the code. So there's actually full traceability of what happens in the project. This is unprecedented. So from an engineering perspective, this is something we can also show to other engineering disciplines. This is the way you can share your work in a digital environment right now. And so for me, the software engineering metaphor, it's not anymore about we're so small and they're so big. It's the other way around. We're the best and they should learn from us. And that's actually also what you see happening now. We work together with a few people in the railway, and they start to adopt Agile, and slowly you see like, there's another way of building trains also in an Agile way.
And you think also that they're not exposed in a way to this knowledge, yeah? Is it because I guess they follow certain standards and they already know so many things, they don't really need
it has to do with standards, but not a lot, I think. I guess from what I see is that they trained and they do electrical design and mechanical design, and they trained in first to a design and then deploy it and then experiment it, because this whole design is the place which is costly. In software engineers, the design is not the costly part. It's the mistakes part that's costly. And so we actually had once an experiment where we doing refactorings with students from the industrial engineers, and the way they write code is they write 100 lines of code at max. And so then if you talk to them about changing something in the code, that's easier if it's only 100 lines. But our students must contribute to open source projects of millions of lines of code. And then there's all of a sudden completely changes the scale of how you think about the code. For the most mechanical and electrical engineers, code is a little byproduct of the real thing. But that's not true anymore. Code is by far the biggest in terms of size in new devices, new airplanes, new drones, new trains, new cars.
It's amazing to hear you speak about this. I think more people should know about this, and I work with people in industry in the railway domain, and I wish they would to be exposed to these ideas more and more.
That's why I do this podcast. Huh?
Yeah. I will make sure that as many people as possible hear about this. And I'm sure a lot of people that are not only people that are experienced and working in industry, but and have a lot of experience, but people that just start their careers in software engineering and software testing. And I was wondering, what's one thing you wish you had known when you began the career? When you began your career, there are two perspectives here, is the research perspective but also the practitioner perspective. What I'm interested in both. The things that you wish you had known.
For the research perspectives, it's research method, research philosophy. So I was really not drawn into academia because of the research. It was only then we started to write our first papers, and then we built a prototype and we tried it out, and it took me 10 years to actually understand that there's a scientific process after that. case studies and little things like that. It was only in 2009 that when I was on a sabbatical, that I actually started to read on these research methods. I created a tutorial. I still give that tutorial occasionally. So yeah, that's one of the things that I wish I had known when I actually started doing research, especially when I had my first PhD students, because I couldn't really explain them how to write and report properly about that. About the practitioner side of things, I'm not really sure. When I started my research, it was on hypermedia, and it was always with the social perspective. And so in that sense, I always had an open eye for what society needed. And so in the beginning, that wasn't really helpful for my career because I was considered too applied as research. But yeah, it always helped me because for me, I don't do research for the sake of research. It's for me to help other people and to be open-minded. And so that's something I was from the beginning on, and that's also something I wish every new researcher should take that stance. You need to be open to the questions that come from society. And now we have ChatGPT and all these kind of things. So there's a world of opportunities going there. But we should listen to the people actually using the software.
Yeah. Since you mentioned ChatGPT, I will take the opportunity to ask you about it. Is it? I guess nowadays we hear about it, and about the use of ChatGPT, and both in education, even in practice, and there are engineers that use it as a search engine. Do you have any opinions on it? On the use of ChatGPT for
I once
in engineering or as students,
I supervised a PhD in art once, and he created notebooks, which was this kind of fancy way of drawing on the screen. And for him, notebooks was the same as a pencil for a painter. And so for me, ChatGPT is no more than a pencil for a paper. It's a tool. And so it's not true that if you say like ChatGPT, write something and it will destroy the creative process. No, that's not true. When painters had new ways of painting, they got better, or they produce different art. And so if we start to use ChatGPT for art and creative processes, we will create different things. Will they be better? I'm not sure, but will they be different? That's for sure. Same for engineering. I mean, we had Stack Overflow, we had Google, now we'll have ChatGPT. This will help us. Will it be better or worse? I'm not sure, but I think we as humans are very flexible and very adaptable, so we will cope.
Yeah, and I guess all the
profession.
Yeah, sorry, no, go ahead.
It will change the profession, and especially for testing. I do a little bit work on generating tests. So it's clear. If you start to generate mutants based on ChatGPT, what will go out? I don't know, but it would be fun to try.
That's interesting. I haven't thought about that. It opens up a lot of possibilities, and I'm sure this will be very, very, very exciting. And maybe this is a good segue also to a question that I have regarding the advice that you have for students getting started in software testing today. So what would you like to tell to students getting started with software testing?
Master students or PhD students?
That's a good question. Maybe we should do both. Let's start with master students, but maybe we should start with bachelor students and master students and PhD students afterwards. Maybe that.
For bachelor students, don't trust the computer. Because that's really, but I already teach how to test software from first year. I also taught how to use software for biologists and things like that. And it's clear, early people just think that the computer is always right. And so that's something, get that out of your system. Computers make mistakes too. So you should test what they produce. So that's for bachelor. And then for master students, if they're really into software engineering, for me, it's about, we teach them now to test software, and they write JUnit tests and the like, and they think that everything is a JUnit test and everything should be automated. And I think that's only partially true. Because if you automate the tests, you kind of test for the known problems. But the actual problems are not the places where you have tests for, where you don't have tests for, and their manual testing is probably better. I once had a guest lecture from somebody from an industrial company producing screens. And the way they tested it was that they just produced a signal so that all screens would be completely red. And then they had an automatic system taking a picture of 100 screens. And then it was one human looking at the screen, and he could immediately see when all the screens will be red or not. If you could automate that, but by the time you automated that, you would have spent so much engineering things, and it takes 5 seconds for a human to do that. So that would be my advice to master students: is, don't go overboard in automating.
Yeah, that's good advice. Very good advice. Well, how about, now I'm like thinking about, since you mentioned also the difference between students, how about PhD students? The PhD students also start in software, they do a PhD in software testing, and then most likely a lot of them will go into industry.
Mm-hmm.
Yeah, what do you have any advice for those students?
If you look into research and tooling and the like, it's often about precision and recall and things like that. And that's not really what's needed by industry in my experience. So advice to PhD students: please don't actually try your tools with real practitioners. Precision and recall is when it's good enough for the practitioners. But what really matters is whether it actually helps them in taking decisions. So there's lots of research now on machine learning for all kinds of software engineering problems. And we did work on bug triaging and things like that. And we actually tried it out with real debuggers. And for them, it's not about how precise it is in predicting things, but can it actually explain why it makes a certain recommendation? And so that's far more important than the precision and recall. And so for me, PhD students, test it out with real people. You will be amazed about the kind of feedback you get on your tools.
I'm glad to hear that.
And then for the people actually going to industry,
keep
that in mind, because the next generation of PhD students will come to you to do experiments. So be open and be helpful to them.
That's a good way to put it. We talked. I mean, I'm just wondering about what you think now. It's a question that just came to mind. What do you think about the state of, current state of academic software testing education? Maybe you can talk about, of course, you can talk about your university, the country, but also Europe or worldwide. I don't know which perspective, but are there any observations that you would like to make, and some things that could be improved in your opinion? I know I
don't really have a good perspective on the state of the practice in education. I only have anecdotal evidence from what I hear. In our university, and that's mainly because I'm there, in the first year, we teach them how to test the software. And what you see happening, especially now with Git and all these kind of things, that they adopt it easier because it's a natural way of doing it when you do it on Git. So in that sense, if you do projects, software testing comes out automatically, I think. But I had anecdotal evidence from other departments, and especially recently some postdoc came along, and he said, like, no, we only teach them how to test in the master. And that's way too late.
This is a very interesting point you're making. And I have a colleague of mine, Ayadele Barrett. She's studying testing education. So that's what she's doing the postdoc on how to improve testing education. And she looked at testing courses in Sweden, and she saw exactly what you're mentioning, that I think at the undergraduate level, they do not offer individual courses on testing, or even you cannot find even modules on testing. So testing comes up later on, and also the software testing courses are just a small part. I think she said something about 5% of the total degree credits are in software verification and validation, which for me seems so little.
Yeah.
And maybe that's why it came to mind. But I think it's interesting when you said it. I think it might be something there.
But whether at undergraduate level it should be a separate course, I'm not that sure about that. Because for me, testing is a natural part of any project you do. And so almost all computer sciences degrees have some form of testing. And so there it should be like, if you do a project, there's our test, because otherwise it's not a project.
Yeah, exactly. Yeah. So Serge, I think I'm very happy that I could have you on Testing Habits podcast. It was a pleasure to talk with you, and I'm more inspired now than I was before, which that says a lot. Yeah, says a lot. And I was just wondering if you have anything to say to the listeners. Where can they find you? Is there anything that you're doing right now and they should check it out? I don't know. And is there a way to get in contact with you?
I'm very open. So I'm on email. I'm still on Twitter. But reach out to me, and I'm always open to discuss things, not only software testing, software evolution, but also the general importance of software in a digital world. So reach out to me.
Great. Thank you, Serge. I appreciate it.
Thank you for inviting me and for having this.